We start off with the variable definitions. We let x be the number of bears, and we let y be the number of dinosaurs. Then we look at each of the constraints. John has a maximum of 20 stuffed animals, so that means x plus y has to be less than or equal to 20. So it can be equal to 20, but it can't go over 20, right? It's a maximum. So there's our first constraint. John knows he has at least 10 stuffed animals. So again, dealing with the total of stuffed animals, x plus y is greater than or equal to 10, right? He's got at least 10, so he could be equal to 10, but there could be more, so there's greater than or equal to. John has less than or equal to 6 bears. So now we're just dealing with the bears with just x. So x is less than or equal to 6. The final constraint says John has at least 5 more dinosaurs than bears. So we start off by writing down both of the variables, x and y. Now we ask ourselves, which one of them is there more of? Are there more bears or are there more dinosaurs? It says there are at least 5 more dinosaurs than bears. So there are more dinosaurs. There are a larger number of dinosaurs. So we put the modifier onto the bears. In this case, it just says there's 5 more. So that means we're adding 5. Now we need to get the relationship between them right to figure out which way the inequality sign is going to go. It says there are at least 5 more dinosaurs than bears. So I like to read these backwards in this case, where I say the number of dinosaurs is greater than or equal to the number of bears plus 5. If I turn it around, that might be a little more obvious. Y greater than or equal to x plus 5. Now, we always have to keep in mind that in this case we can't have negative values. So x can't be less than 0 and y can't be less than 0. So we always have to have our 2 additional qualifiers, x greater than 0 and y greater than 0. Now that I have all my constraints defined, I want to get them into the y equals ax plus b format. So we take this one, we're going to subtract x from both sides. So we get y less than or equal to negative x plus 20. Same thing with this one, subtract x from both sides. We'll end up with y greater than or equal to negative x plus 10. The x less than or equal to 6, we don't need to change. I've already worked through this one, so we've already got y greater than or equal to x plus 5. So let's go ahead and start graphing them. So we take this first equation, and we look for the b value, which gives us the y-intercept. In this case, it's plus 20. Put that on the graph. We look at the slope of the line, which in this case is just negative 1. There's a 1 implied there, even though we don't always write it in. And we know we can always take any whole number that's a slope, or take any whole number and divide it by 1. It's not going to change it. But it helps us understand that we've got a negative slope, which means we've got a negative rise over a positive run, which means we go down 1 and over 1. And we put that point on. Now we can use a straight line to connect those points. And put arrows on the end of the line. Then we need to look at the inequality and figure out which way the shading goes. Because it's less than, that means the arrows go down. So we can go ahead and draw on the arrows indicating less than. Take our next line, y greater than or equal to negative x plus 10. Same process, our y-intercept is 10. Put that on the graph. Same slope, negative 1, so we go down 1 and over 1. Put another dot, and now connect the 2 dots with a straight line, and put arrows on the end of the line. Again, look at the shading, and this time it's greater than. Y is greater than the rest of the equation, which means the lines go up, so the shading will be above that line. Take the next line, x less than or equal to 6. There's no y value involved, so regardless of what y value we consider, x will always be less than or equal to 6. So we can put that here on the map, here on the graph, and that means we've got a straight line going straight up from there. Now, it's got an inequality of less than or equal to, so that tells us the number will have to be on this side, because this is where the numbers are less than 6. Next equation, y greater than or equal to x plus 5. The y-intercept is 5, so we put that on the graph. This time we've got a positive slope of 1. So we go up 1 and over 1. And again, connect the dots with a straight line. And the shading, and this time again, it's a greater than, so it means we're shading above the line. Finally, looking at our last two constraints, x greater than or equal to 0 and y greater than or equal to 0, that means we're on the positive side of both of the axes. When we look at where all of the shading spaces overlap, we can see that the blue comes in here, the yellow comes there, green comes over, red comes down. So it's this space in here that is the polygon of constraints. So to highlight it a little more, I'll put a black box around it. So that's our polygon of constraints. Now we'll identify all of the vertices of the polygon. Call this A, this vertex is B, this vertex is C, this one is D, and this one is E. Once we've identified the vertices, now we need to figure out what the x and y coordinates are for each one of those. So let's start with the A vertex. A is the intersection of two lines. It's the intersection of this red line, which we said was y less than or equal to negative x plus 20, and the y-axis, which is x greater than or equal to 0. So let's take those two equations and solve them as a system of linear equations. So as we mentioned previously, we don't really need to work with the inequalities now because we're talking about the intersection of two lines. So y equals negative x plus 20 and x equals 0. The way it's set up, we've got numbers that are good for substitution. So y is equal to 0 plus 20. So vertex A is 0, 20. Let's look at vertex B. Vertex B is the intersection of that same red line and the green line, x less than or equal to 6. Again, dealing with equations, negative x plus 20 and x equal to 6. I'm going to take this 6 and substitute it in. So we're using the substitution method again. Y equal to negative 6 plus 20. So y is equal to 14. We've got our x value, so vertex B is 6, 14. Vertex C is the intersection of the yellow line and the green line. So x less than or equal to 6 and y greater than or equal to 5. Convert it to equations, and once again we can use the substitution method. So we get y equal to 6 plus 5. So y is equal to 11. So vertex C is 6, 11. Vertex D is the intersection of the blue line and the yellow line. So y greater than or equal to negative x plus 10 and y greater than or equal to x plus 5. In this case now, we've got two variables in both our equations, so it doesn't lend itself as well to substitution. However, it does lend itself well to comparison. So we take right side of both equations and we bring them down and put them equal to each other. Negative x plus 10 is equal to x plus 5. Now all we need to do is solve for x. So I'm going to add an x to both sides, which gets rid of this negative x and gives us 2x over here. Now we want to move the 5 over to the other side, so we're going to subtract 5 from both sides. We end up with 5 equals 2x. When we solve for x, x is equal to 5 over 2, or 2.5. Now we've got an x value, but we need to get a y value, so we're going to substitute that back into one of the equations. We can pick either one, but I'll pick y equal to x plus 5. I take this 2.5 and I substitute it in for x, so y is equal to 7.5. So vertex D, we have now found, is 2.5, 7.5. And last but not least, vertex E. Vertex E is the intersection of the line y greater than or equal to negative x plus 10 and the y-axis. So y equal to negative x plus 10 and x equal to 0. Once again, substitution is the best method here. So we can say y is 0 plus 10. So y is equal to 10 and x is equal to 0. So the vertex E is 0, 10. So to summarize, the vertices of the polygon of constraints are 0, 20, 6, 14, 6, 11, 2.5, 7.5, and 0, 10. So it's A, B, C, D, E. Once we've got the vertices of the polygon of constraints, we now need to go back and find the target objective. So let's go back and look at the original problem. The original problem asks us what is the minimum value of John's collection and how many of each animal would John have to have if his collection was worth the minimum value. So we're looking for a minimum value in this case, so that's our target objective. Now that we have the target objective, we need to come up with the optimizing function. In this case, we're working with total value. So we'll set total value equal to the number of bears times $10 and the number of dinosaurs times $5. So the number of bears times 10, so there's 10x, plus the number of dinosaurs times 5, which is 5y. So that's our optimizing function. Now once we've got the optimizing function, we need to test each vertex to see which one of them gives us our minimum value that we're looking for. So let's go ahead and start with vertex A. So we take the coordinates of each vertex and put them into the optimizing function. I'm going to shorten total value to just be TV. And we take the x and y values, so x is 0, y is 20, which gives us 10 times 0 is 0, 5 times 20 is 100. So the total value at vertex A is 100. For vertex B, we follow the same approach. Substitute in 6 for the x, and we carry on doing exactly the same process for each vertex. We now have the total value at each of the vertices, and we can easily go through and evaluate which one gives us the smallest value, or the minimum value. We've got 100, 130, 115, 62.5, and 50. So clearly, 50 is the minimum value. We were also asked how many bears and how many dinosaurs does he have when he reaches that minimum value, and that information is right here. X is the number of bears, y is the number of dinosaurs. So our final step is to give a summarizing statement or the solution to the problem. So we say the minimum value of his collection is $50. And that minimum occurs when he has 0 bears and 10 dinosaurs. And that's the final solution to this problem.